Good morning, everyone. My name is Alistair Moore, and on behalf of CIBSE West Midlands, we welcome you all to this presentation today. Just get a few things sorted before we kick off. There's a chat function that we'll be running with our Q&A. So if you have anything that crops up during the presentation, we can run through that from there. Our presenter today is Paul Fawkes from Thebden, and he's going to give us a presentation on smart buildings now and also a little bit about where we see them going in the future. So I'll hand over to Paul and let him introduce himself, and we'll go from there. Thank you.
Good morning, everyone. Glad to see a really good turnout. My name's Paul Fawkes. I've got the two hats that I bring today. I work for a German building automation manufacturer called Theben, T-H-E-B-E-N, and I am also the president of the KNX UK Association. Those of you that know KNX will sort of know what that's about. Those of you that don't, by the end of this presentation, by the end of this CPD, you will hopefully know what that's about. If you haven't, then if you don't, then I've sort of missed the mark slightly on that. The presentation today about smart buildings, it is a CPD, so it is set within a certain set of constraints. I said we're going to be talking about building automation and looking at the sort of how building automation and smart buildings, you know, how the two sort of run together side by side. And the way to achieve a smart building, I think that's the end goal, is to look at, you know, what makes a building smart, how to get there. Some of the sort of, hopefully you'll pick up some of the pitfalls as we go along as well, and sort of those things to be aware. You're all engineers, you're all very aware of your particular fields. So I don't know if you're all from the construction side or this is a sort of slightly broader base. Hopefully it's a broader base as well. Which you'll see is important, getting that broader base out there. And then just sort of at the end, want to have a quick look at, you know, smart buildings in the future. It's my particular viewpoint of what we should be aiming at and where we should be going. And we'll sort of run it through from there. As Alistair said, we've got the chat box open on the right hand side. Please feel free to put in questions there. I'll either answer them as I go along, or they will be answered as we go along, or we'll save them up for the end and then cover them specifically at the end then. Okay, but please do just put stuff up there, even if it's something quite general, then we can do it from there. Now, hopefully, if I will share my screen. And you should now see, yeah, everything comes up fine, my screen there. Okay, there's only one small issue for me, is that I can't see the chat box, but I know Alistair is monitoring that. And if need be, then Alistair can throw in and jump in and get some.
Will do. I'll sort that.
Thanks, Alistair. Thank you. Okay, so smart buildings, yes. Building automation solutions for residential, commercial, and industrial applications. It's not such a snappy title as smart buildings, although these days I think the word smart, it does sort of, yeah, it makes me a bit mad sometimes when you hear smart, sort of similar to when you hear green all the time. You know, we've got greenwashing. Are we moving into an era of smart washing? Where, you know, you just add the word smart to something and it apparently takes on a completely new persona. And these are sort of stuff that we as engineers need to be very much aware of. There's a lot of smart gadgets out there, and they truly are gadgets, and that's something that you know, we should be aware of. There's nothing wrong with using those. But it's certainly something that we should be aware of. And with KNX here, as you'll see, it's way beyond the gadget. We are talking about full building automation solutions. So let's just get on. Okay. Come on. There we go. Sorry, slight glitch there. So building automation, what is it? Building automation, it's integral to building design. Efficient building automation, efficient building operation, occupancy comfort, improving energy efficiency, reduced maintenance costs, security, improved building life cycle. So building management systems, they are integral to the building design. And there are counter solutions for building control on the market. I'm sure we all know of at least sort of 3 or 4. BACnet springs to mind, DALI springs to mind as well. All of these we touch on during the presentation. But many of those systems control one part of the building, such as lighting or blinds or whatever it happens to be, plant control. And there are other systems that are specific to a control level, such as supervisory for plant control. Again, these are very sort of common areas of building automation. BMS, building management system. So the choice of BMS can actually be quite daunting when you're looking at your building overall, and this is something that we'll be touching on constantly throughout this, as you'll see. And especially at the design segments of the building project, they can often be siloed by their approach. Unfortunately, the very much the UK approach to building design and implementation is very siloed. The architect can often be separate from the designer, which is often separate. But we have M and E. And as I think we all know, sometimes the M's and the E's, when it comes to construction, the mechanical and the electrical, they don't talk to each other, and this can lead, say, to that side. Well, it is that siloed approach, and this can lead to actual fundamental design problems with buildings. So what we need to do with a truly smart building, with a truly integrated a building, is to truly integrate these systems of control. One protocol would be perfect. Is that protocol there? Is that protocol available? Well, actually, yes, it is available. I'm having serious problems with my keyboard at the moment. Just a second. There we go. Sorry about that. So I seem to be having problems with my keyboard. It's not wired. So by using a protocol that can act at all levels, the system designer, that could be some of you out there, you can mitigate the risk and manage the control of multiple systems. So KNX is a protocol that is effective across all the building systems and at all control levels. So it can deliver functionality and performance. It is scalable. It's certainly usable from all levels. So from actual end user all the way up to facility manager or asset management, remote asset management as well. It's certainly reliable. It's efficient and longevity. Hopefully I'll be able to prove some of these to you as we go through the session today. So is a smart building simply building automation? Let's discuss. So really, what are those differences? I think the difference, building automation is reactive, whereas a smart building should be potentially proactive. So you are reacting to multiple inputs. So that's occupancy, time, weather, energy constraints. And what I mean by energy constraints is we are moving to an area into a time when our demand side response needs to be incredibly effective for our buildings. So an effective reaction to that energy production is important. So if that needs to be brought into a control system, so when the grid is low in that particular area, then that heating system of that building can be reduced, or the air conditioning system, and this can build up over time as well. So it's building up an information bank within the building itself. So all of those things are being worked at the same time. And a mixture of these inputs as well. So they will definitely change. Obviously, the occupancy during the day is going to be different from the occupancy at night. It might be higher, might be lower. If it's a factory that runs on mainly night shift, then that's something that needs to be accounted for. But this should be stuff that should be done automatically. And I think that's the key difference between simple building automation and smart buildings, where that smart building really assesses and has a massive overview of exactly what is going on in that building and around that building as well, all the time. So the building is always looking for the most efficient outcome. So the building becomes the core control element. But to really achieve this, you need multiple protocols. But the key thing is they must work together. They cannot stand alone, not for it to be a truly smart building. And the multiple agencies that are involved, as I already said, you've got the architect, you've got the designer, you've got the owner, you've got the developer, you've got the mechanical, you've got the electrical. There should be an ME and I in my mind, the mechanical, electrical, and the integrator, or the information side of stuff. All of these need to be brought together at one point. Across mainland Europe, I worked out in mainland Europe for 20 years. Lived out in France and lived and worked out there, and they do come to the table in a slightly different manner. Not every project, believe me, it's not some sort of halcyon world out in the European Union, certainly, but they do have a tendency to sit down together right at the beginning of the project and work it through. And that's something that's really, really important. And say, unfortunately, as I touched on earlier, that system doesn't necessarily work so well in UK. And integrated, so all of that, so those protocols, those agencies, whatever it's doing, it needs to be integrated. Integrated is that key word to me. I'd rather talk about an integrated building rather than simply a smart building. So having an integrated building is smart, or is it smart building? I'll leave that up to you. So true integration needs a true building automation standard. KNX certainly ticks that box. It became the European standard in 2003, the EN 590. It became the international ISO standard in 2006, and became the Chinese standard 2013, and the Australian technical spec standard in 2017. We've moved on as well also with the data security systems, and it brings together many international standards as well. So the SANLEX-N, the ANSI standards as well. So it certainly sits in there with bringing that integration of standards, not something standalone. It's not setting itself up. It's not trying to reinvent the wheel. It is something that brings together these automation standards. But it also requires a level of flexibility as well. So you've got to be able to have all of those multiple inputs and multiple protocols. I think that is very much an issue within the construction industry and within the sort of the environment that we live in, where it's very everyone's bidding for the same set of jobs, is that everyone wants to sell their particular protocol or their particular solution. And the key is you end up with unintegrated solutions. Whereas if you put in a central backbone, you can run multiple systems off that with multiple gateways. This allows you a really level of flexibility, so not only you but that end user, that end developer as well. So if you're doing if a developer is just selling out a single floor, then if you've got a core system that can take in all of that information off that floor, then that that floor can be run by DALI, it can be run by DMX, or it can be a Modbus base, but it will feed back to a backnet plant control maybe. But having that flexible core is really, really important, and that is applicable in any building, really any building size. So it's that backbone integration, as it says there. So KNX, we've looked at what it can do, what it potentially brings. So history, is it something new? Is it a new forerunner? Well, you saw that it became the international standard early on. It started as the EIB in 1999, European Installation Bus, it came together as a number of leading manufacturers across Europe to create something that would tick all the building automation boxes. Excuse me. And you know, it's moved on from there. It now has 500 worldwide, more than 500 worldwide manufacturers, more than 8,000 different products, and it's increasing all the time. So, you know, KNX has not been around. KNX has been around for over 30 years. It is still absolutely relevant. It's not out of time at all. So that's a brief history. The functionality, it's always looking at that core element. So you're looking at, it needs to be able to have an influence upon everything that we're talking about. Smart building is a building that reacts to every single element within it, but is also proactively controlling those elements with information from the other elements as well. So systems and security control, energy management, lighting control. There's so many electrical and mechanical options for a building. You know, this is it's essential that you pick that absolute correct core. And the KNX world is a distributed intelligence world. So the product within each of those environments has its own level of intelligence, has its own level of control. There's very few weak points. Even the power supplies, you can put multiple power supplies onto the bus line. So this prevents, you know, even with power, even with a power supply failure, you're still not losing your central control. Also, that makes upgrades and changes considerably more cost effective. And as I say, as we were sort of talking about earlier there, KNX can be coupled to many systems via gateways, wired and wireless. So through from BACnet, Bluetooth IR, N-Ocean, DMX, DSI, DALI. I'm sure some of you will know some of those, if not all of them. Your building's at the center, so you can have wired and both wireless. So into the N-Ocean, Z-Wave, Zigbee, Wi-Fi, Bluetooth, and of course into IoT as well. So it's an IT backbone can be run on that as well, which we touch on a little bit later. First of all, so let's have a look at what is KNX. Where does that fit within our smart building desire? It's a standardized language that allows products from different manufacturers, those 500 plus manufacturers, to work together to control all of the aspects of the building, all the environmental control. So it works via multiple mediums, which we'll come on to on another slide. And it's configured by a single piece of software. And the standardization includes product testing to ensure that the system will always work as advertised. So each item, each KNX item manufacturer, and then each item carries the KNX logo, and that means that it is come up to the KNX standard. So you're getting something that is a known value, a known quantity, and they are 100% interoperable forwards and backwards. Personally, I've been into a site where there has been equipment that's 24 years old now. 24 years old. This is and it was a failed dimming unit. Not bad for 24 years old. and I put in a brand new dimming unit straight in, altered the program to reflect that, and off it went. So it is 100% guaranteed forwards and backwards compatible. That is absolutely one of the key things to KNX, and that is one of the things that gives it its inherent financial rewards in the long term. Now, KNX is a one cable solution. The 3 levels, but even though it's the one level of one cable solution, the 3 levels of control are still used. So field level, automation level, and supervisory level. But KNX allows more protocol across the whole project, from field to supervisory. And the product's available. It's from wall fixtures and fittings through to environmental control, monitoring. That's a Dali gateway, and all the standard sensors and stuff that you'd expect to see. So it can easily monitor everything from light levels through to occupancy, through to VOC content, and then can control ventilation, windows, heating, cooling. And you can have your local control if need be, or in a commercial situation, then you'd want that maybe plant controlled, or even remotely asset managed. So your building in Beijing might be run from an office in Frankfurt, certainly monitored at those distances, and it can be run from those distances as well. So performance, I say over 500 manufacturers, it does mean that you can always specify the right product. So again, ticking that box for that, making that building smart becomes so much easier. You're not limited to 1 or 2 or 3 manufacturers, but sometimes it's just one manufacturer. You can really look at, I want to measure wind speed and outdoor light, but as well as interior light and interior occupancy and the temperature and the humidity. Well, you don't have to stick with one within one manufacturer. You've got the multiple manufacturers that do each of these multiple options. That really gives you as an engineer the option, the capability to tick that box. When that client wants that smart building can be supplied. The distributed intelligence means devices are designed for their specific application. Now that's, so you're not picking something that is well, it will do. It is a product that is designed specifically, say, to count people in and out of a room. There's a product for that that can produce heat maps for that room. There's a product specifically for that, and obviously products certainly with sensors here. You'll have products that will do not only occupancy, so there'll be automatic and semi-automatic, but they'll also be, it will also measure temperature, it will also measure sound measurement as well, in one small compact device. And this also enables off-site build and, encourages modern construction methods as well, MMCs. You always meet the brief. You don't over-specify. Why put in a £1,000 detector when a £80 detector will do? So the cost constraints are met with ease. Gives you that speed and simplicity of deployment, and the inherent security as well, because it gives you a larger field of people to work from. Bus cabling, we'll sort of run through these reasonably quickly. The bus cabling is easy to install. This is very specific to KNX, and you can run it in your trays with mains voltage as well. And the scalability, this is what I was talking about earlier, this is quite interesting, because you've got the standard wired connection, you've got an IP connection as well. So generally now in the larger buildings, you'd have an IP backbone. Well, that's fine because we work across IP backbone. And there's also wireless as well, the RF connection, obviously. There's certainly on residential, and I know from my experience as a residential installer, it doesn't matter how much you coach and cajole your client, right at the end when they're plastering or painting, they then say, oh yeah, we would like a switch over there actually, and if you can't get that cable down to it, then having that RF option is always useful. We always call it a get out jail card free. It's always handy to have, but it's a centralized system architecture. This is the key thing. You can use one or all of these. The IP system, say on the commercial buildings, that's an absolute key. So the scalability. How many solutions do you need for different sizes or buildings, types of buildings? And is it possible for one system to work on any size or type of building? Working with a centralized system architecture means that you're often using hardware that is over-specified. But it can handle a range of building sizes. Because KNX is decentralized, you only ever use the parts that you need. So it could be 2 products for a test system, or 60,000 products, in an extremely large building. It certainly is scalable. I have this in my house. The house I'm sitting in at the moment is KNX. I'm moving this year to a little cottage in North Devon, which is at the moment we are going through the renovation, and that will be KNX. I have a house from my time in France that I designed and built. That is KNX. But also the British Library, part of that is KNX. Terminal 5, Heathrow is KNX. The Beijing Birds Nest Stadium is KNX. So scalable, certainly, from small all the way up to, from small residential all the way up to high levels commercial. Each of the devices has its own processor and the ability to communicate directly with any other device. So you never carry the overhead of systems. You just add the devices that you need to suit the size of the project. It's a topology that's broken down, as you can see here, with lines, and then couplers between the lines, which keep the security down. You can have the IP backbone. This would, on a larger building, this would probably be an IP backbone to increase your scalability. And each of the areas can operate independently within their area, so they're not constantly going back to a central point. You only allow through the coupler what information you want to allow through the coupler to a central point, central plant control maybe, or weather information coming from outside the building into the system to make changes to the environmental controls. So it makes an incredibly scalable system. And this is the absolute key part of a smart building, is making sure that all of those areas talk to each other, from all the way down from your light switch on the wall to your plant control of whatever building it happens to be. As that one person in that one meeting room wants the heating up slightly, that information has got to pass through the whole system, through that whole area, and be able to react at the plant, which could be 40 floors lower down or whatever it happens to be. And that's absolutely key to having a smart building, is being able to react easily and scalable across those areas. Say 255 devices per line, 15 lines per area, 15 areas per system. So it's a maximum of just under 62,000 devices, which is sort of pretty much sufficient. Certainly does my house. KNX over IP, it gives you the additional flexibility on large buildings. It's interoperability with multiple protocols such as BACnet. So you start expanding your capacity limit. There's no bus traffic limitations. There is a limit to bus traffic on the KNX bus, although with correct control, the right use of areas and sections and couplers, you reduce those bus traffics, and they can be parametered as well. Reduced cost installation, I'll have to get back to you on that one. You can use existing networks as well between buildings, and KNX fiber optic option is available as well. So you're each running through your hub switches out through to your gateways, and then the whole point of KNX Secure as well, secures and encrypts all of these devices. Also, if you're going to stick it onto IP as well, obviously, then that becomes part of your remote asset management. So pulling in a number of different buildings, maybe across a university campus or potentially across a wider area, say, buildings spread across the world, but you want a centralized asset management. Scalability and performance, scalability topology for any project, any size, as I've said. Wiring simplicity, it's simple to install, flexibility, use of different mediums, decentralized. So you can add additional products as requirements change easily. We're going to have a quick look at usability. You're not going to concentrate too much on these, although, you know, that smart building needs to be something that a user can use. So system interfaces are important. Keypads, apps, voice control, and automation. The voice control is something that, even though I'm I use KNX on a regular basis, I don't actually use voice control in my own house. But I work with work sometimes in the assisted living environment, and certainly a voice control is something that is really useful to certain people, or certain, you know, those requirements within that area as well. Voice control, it takes away that control. But there are other areas, certainly, say it's interesting with the assisted living, where you can actually run KNX via gaze control, eye gaze, sorry. But other actions as well. As long as you can bring in an action, you can monitor that action. So whether it be eye gaze or whether it be voice control or whatever it happens to be, then that can be brought into the system quite easily as a control element. So this brings you that integration into facilities management. This makes your designing of a system really, really straightforward. Because it gives you multiple levels of control and monitoring as well. So localized monitoring, we can say down to the Apple Watches, simplified visualization, local visualization, and then system controls as well, both obviously via your phone and via apps as well. But also that goes beyond, way above and beyond this on commercial systems, where you bring in that entire control management. But all of that information is available, that's floating around on the bus. It's all available. So if you had a care facility, for instance, and this is where buildings become smart, you have a care facility, you have all of that information available to you, but then what, say, a nurse wants to see is going to be completely different from what the local facility management wants to see to what the asset management wants to see. But it is easily separated out. It's having that information all there and then being able to relay the specific detailed information to that specific person, what they want to see. And that's really, really key to, in my mind, to having that smart building, is being able to adapt that information as well, and to exactly the end user who needs it. And even just on a local control in your room here, you need to know, what the temperature is, or what maybe that scene setting is. That's all that person needs to know, and they can alter that. So it's having that usability and flexibility. Say accessibility to all users, the controllability and the management, and a choice as well. 8,000 products. Okay, not all of them are end user facing products, but 8,000 products, 8,000 choices for how you want to achieve that end goal. That really allows a level of flexibility for you. Reliability, decentralization, individual devices can fail, but the system doesn't. Design within the product and system limits, and it will work. These are sort of like a quick overview of the limits of 700 meters maximum between two devices, and any amount of those devices in between, up to 62,000. Power supplies no more than 350 meters from a device. Segment lengths and device maximums on those segments. So it's staying within those, but it's a standardized setup, and it's very, very simple. Energy savings. This is, I think, a slide that everyone puts in at some point of their system, and it's certainly acceptable. But I think, it goes almost without saying, but we have to say it. A smart building has to be an efficient building. There's no question. It has to be, and that has to be one of the key things that it brings to us. That has become so evident in the last 6 months with rising fuel costs. There is just no There's no way around this, and this is going to make it really, really important to the individuals, and I think the smaller end of the smart building market, the smart houses, but not the smart houses for footballers and celebrities, the smart houses that we all live in, by being able to really, really control your heating room by room, hour by hour, minute by minute, looking at your device control, and we'll actually touch on this just right at the end. Efficiency, yes, transparency and cost, design the efficiency into the building. There's energy savings for the mechanical and the electrical services. One infrastructure means there's less material within the building. Life cycle cost management, so you're actually, the amount of time the stuff is going to be in the building is longer, and that is more efficient. And sustainability is how long it lasts, not only how it's made. So these are high quality, products made in ISO 9001 factories that are agreed and assessed and viewed. So it's how it's made, but then that sustainability is how long it's going to last as well. These products will be in buildings, should be in buildings for 20, 30, 40 years. And that's important, and they still work, and they still work within that protocol. There's not many systems, there's not many things. You can go back 30 years ago, you could buy a VHS tape now, but you might have problems trying to play it on something, or a floppy disk, or anything else like that. So this is a protocol and a building automation system that is truly smart. Guaranteed interoperability, leads to savings, improve the building functionality over time. Longevity, well, construction can be a harsh environment, and installations have to be robust through their entire lifetime. The robustness is not only guaranteed by the material and the manufacturer, but by the install quality and the post-install support and the service opportunities. So a single protocol means less cabling, fewer power supplies, less gateways means more compact distribution panels. This simplification speeds up the planning, reduces materials in use. This in turn has a positive impact on our environment. That to me is also something. A smart building is not something that litters the environment. KNX, excuse me, sorry. The building is not just a simplified structure, it is a sum of all its parts. So the long-term sustainability of that building will eventually be measured by for how long it can perform its primary function. That function may need to change over time, but if that change requires less material replacement, less wastage, then the sustainability will be improved. Sustainability, longevity, they work hand in hand. And I'm sorry, as far as I'm concerned, but so does smart. That smart building has to be that. Whatever that building, whether it's a single residence or whether it's, a huge commercial building. With 100,000 partners worldwide, you can find those people to help you. 500 plus manufacturers. It's been around for 30 years. It's 30 years strong. And it looks back with compatibility, and it's looking forward with some cutting edge solutions. So KNX is leading the changes into building automation. Any system needs to be prepared for the full impact of IoT, which is constantly changing and adapting. 5G and beyond. I've already heard talk of 6G, and we haven't even got 5G yet. So that environment for connectivity needs to make sure that KNX is adaptable for that, or a smart building, excuse me, whatever it is. They must all be integrated, whatever it happens to be. KNX is already active and working with EV charging, energy storage, smart grids, and demand side response. We'll have a look at this in a second. IP Bliss. This is stuff that is going to be available to you anyway, but this IP Bliss is bringing together these participating standards. This is worth looking at. BACnet, the CSA, DALI, Alliance, the Thread Group, Open Connectivity Foundation, which I believe is the ZigBee, I believe, and KNX. This is bringing together the building IT network. This will be a smart building. If you bring in this level of connectivity and integration, you will have a smart building. Yes, covers the diversity. We're sort of getting through to the conclusions, some of the conclusion slides. A summary of what KNX can deliver: efficiency, performance, usability, functionality, reliability, scalability, security. Hopefully I've been able to sort of get that across. And these are all of these elements here, they all tick the box of a smart building. If any one of these is not in your building, then it's not a smart building. It's as simple as that. That is why KNX is the solution for building control. Maybe should we say that for smart buildings. Find out more at the website. Multiple levels of projects across the world. Projects in UK. So I'm going to flick through these. These aren't specific to what we're talking about today. But the future. I was asked by Alistair to do a sort of quick overview of my future of smart buildings, and this is something that I put together. This graphic. My apologies for the low level of readability of it. Hopefully it does get it all across. It's a little bit easier once you have it in front of you. But this to me is smart building, and is where smart buildings should be going. And it is the integration of bringing all of this information of our buildings together. So I happen to use, obviously for this, I'm talking about KNX, because KNX, as I've explained, works on any size of building. It's scalable, and it becomes part of that centralized integration and connectivity. And this to me is where our future lies. Not necessarily in new technologies. I mean, it's just making the technologies that we have right now work right now correctly. We can do all of this now. We can demand side response. We can bring in alternative energy production solutions from renewables and biomass and anaerobic digestion, for instance, from farming. And we can bring communities together. We can bring those houses together, these facilities together as a single simple asset, and part of that is community energy management, and we sell excess production back onto the grid. This is all perfectly capable now. Vehicle to grid, battery storage, sharing battery storage across buildings, PV charging vehicles. We need to stop trying to reinvent the wheel. We have these capabilities now. What we need to do is act on them and make sure that they are installed now, that these work now. We are building houses now that just don't come anywhere close to this. So these are not smart houses. These are dumb, and as dumb as you like. Anyone here within the housing construction sector, we are using a wiring system within our houses now in 2022, which is the third decade of the 21st century, that was basically put together. The fundamental core of it was put together in the 1950s. That is not smart in any way. It's not a smart building, but it's not a smart way to build. On that little soapbox rant, I'd like to just finish off from there. So KNX smart buildings, say design efficiency, saving you time. It's one infrastructure, which is less complication, uses only the products you need because of decentralization. It's got a multiple set of medium types, so there's always a solution for what you're looking for. There's risk mitigation because it's market proven, over 30 years market proven. It's cost efficient because you're using less material, and you're designing for the future. It's sustainable. So these are all smart things for a smart building. That just about finishes me up. Any questions? I'd like to open up the floor. I shall.
I've got a couple of questions actually, Paul, that have come up on the chat. If I can ask them and you can comment on them, that would be great. First one. Oh, if I just go back. First one. Our first question is, interoperability is a key issue. Clearly, other manufacturers have to design for this too. But how much data exchange is there in theory and in practice? Lighting is a key area. Can data be received on things like running hours and faults? And is it transmittable?
The answer to all of that is yes. Yeah, basically, a simple answer is yes. As I said, the beauty of the KNX protocol is that it is the core. It can be a core protocol, but it can also easily control all of your lighting. I think across UK, certainly on the commercial side of stuff, DALI is the go-to solution. DALI 2 now has certainly moved that into an era where it is much better. And KNX has the DALI 2 gateway. So your core element, your core control could be KNX, and then DALI lighting across say your floors. So yeah, you can pick up all of that information, everything that a DALI system does, product failure, hours counting, anything that you need to do. But also, I think one of the great things is that even with a DALI detector in your room, it still sends a signal onto it still dumps the signal onto the KNX bus. So you could actually use that to, when you want the lights turning on, you can also let the heating system know that someone is there in the room and the heating needs to come up to a certain point. So you've reduced the amount of, you're not having a detector for your light control and a detector for your occupancy, say, to manage the heating. And also that light control, if you've got an office that's got a lot of windows, then it can control your blinds as well. So this becomes that whole interoperability of shading, of environmental control. So just from one lighting detector, you can measure the light level, you can measure the temperature, you can then affect the shading, the heating, and exactly what you need it to do. So absolutely, you know, that information is out there, or the information is available on the bus, certainly.
Okay, another question here. This one's from me. I spend a lot of time in district communal heating, and demand side response is key. I love the idea of connected networks communicating energy demand to the grid. You mentioned that's possible now. Why isn't it happening? What's the issue?
Do you know, I'm sorry, Alistair, I can't answer, and I don't know. I came back to UK in 2012 after, say, being over 20 years in France and living on continental Europe, and I was sort of quite shocked at the sort of like this level of connectivity that we don't have. You know, everyone wants to talk about their phone being connected, but no one seems to want to talk about their building being connected to other buildings. And that demand side response is absolutely key. And it's interesting that I just put my Tabern hat on. Tabern have produced a product called Connexa, which you put into that. It's a small DIN rail mount, 4-module DIN rail mount product. And with a smart building, so a KNX building, it can take all of the information in that building and it bounces it back to the supplier, the DNO. So it's a smart meter, and it's been accepted across Germany, across the federal, the national government, as the way to smart meter. It's also accepted by France and Scandinavian countries, and I think it's about to be accepted by Holland and Italy. But unfortunately, it is not acceptable. It doesn't fit into the criteria in UK because we use the SMETS. Now, this isn't my area of expertise. You probably know far more than this. But why isn't SMETS? Why isn't our smart meters capable of picking up on this information? Surely that is something that we need to know. We should be able to not just know when energy usage is up or down within a building, but we should know when a customer, or a resident turns their washing machine on and off, turns their dishwashers on, turns their heating up and down. This is information that we can do now. Say they are starting to do now in Germany. That is fed back to the DNOs. But honestly, I'm really sorry. I'm afraid why? Aren't we the people that should be championing this and shouting about it and trying to change it?
Okay, thanks very much for that. The other question I have is, you mentioned before you went on to IP about the one cable solution. Are there any inherent problems that may occur by running a one cable network around a building, just in case it drops off in any position, that kind of thing?
I've never come across them, and as I say, it's a case of planning the system as it's installed. So the system, I'm just trying to think what size cable. I think it's a 0.6 millimeter twin bus cable, So it's quite robust. It will take a, it'll take a good knock with a hammer without it being damaged. You can run it next to mains voltage without it being, without the signal being affected. Most of the KNX cable is actually 2 pairs, so there is actually always a spare pair in case one gets damaged. And it's a relatively simple cable. It's a simple bus cable. When I'm explaining it to non-technical people, it's a bell wire to all intents and purposes, or speaker wire. So it actually, if you can identify where, say, that break is, that physical break is, once you found that, it's not complex to repair. You just put a Vargo connector in, or you wouldn't want to, but you could actually repair it with a terminal block, a simple screw terminal block. So it is very robust. Say problems, it's not the sort of thing that we come across on that side, no.
Okay, that's great. I have another question here. I think it's the last one we've got. Question is equipment status available? I.e., if a compressor, boiler, luminaire has a fault and you want to interrogate or adjust the machine settings, can you?
Yes, you can. You will be able to get the information of, say, like a particular pump will be dependent upon that pump, but you can monitor, say, the energy usage of that pump. For instance, here at my house, I monitor the energy supply going to my, this is a very simple explanation, view of looking at it, the energy going to my fridge compressor, so that I know that if, and I've got it set parameters so that I can't remember what the actual setting, let's say it's 300 watts for my fridge compressor when it's just turning over normally. When the door is open, that will go, the compressor will turn on and it will run at 500 watts. If I've got that set so that if that 500 watts runs for, I think, 45 seconds, then it will send me a notification to say that go and check your fridge door, because your fridge door might be open. And also as well, what that will mean is as that pump compressor gets older and starts to use more power, I could parameter that to say that if it starts using 400 watts on a constant basis, then it will send me information. So you either monitor that information as it goes into or out of the product, out of the pump, whatever it happens to be, unless that actual item has the ability to send information, such as like a Dali ballast, sending that information back. So yeah, you can absolutely monitor. The parameters are very, very, there's a huge amount of parameters. The other thing as well, the actual devices themselves, most of them have a heartbeat as well. So they can send out a heartbeat onto the bus once every, again, you parameters say once every 30 minutes, just to show that that device is still working. And you can monitor that, say, remotely as part of your asset management. So if that, pump actuator fails and doesn't send out its heartbeat, you will know straight away that that actuator has failed and that pump will not turn on because the actuator has failed. So it gives you a lot of information.
Okay, well, thank you very much for that, Paul. That's all our questions up. On behalf of CIBSE West Midlands, I'd like to thank you all for your time today. Those of you who have requested CPD certificates, we'll get those emailed to you, and we can go from there. Thank you all for your time, and I hope you have a good day.
Thank you very much.
Thank you. Bye-bye, everyone.